In this video, I'm going to be talking again about why high-fat diet or a high cortisol could reduce megalin, and megalin is needed for vitamin B12 intrinsic factor complex. So I've covered in other videos, but this one's going to be different. This time it's going to be about zinc and how it can lead to low zinc. Okay, there are these zip transporters for zinc. So they're a family of proteins that mediate zinc uptake into the cytoplasm from outside the cell, and contains metal binding motifs, often rich in cysteine and histidine residues. Okay, so there's a ZIP4, and ZIP4 uses cysteine residues in order to sense and transport zinc. So thiol groups of cysteine, they coordinate zinc ions, and they help maintain proper protein conformation and transport function. So in other words, cysteine helps zinc to be transported by ZIP4. Vitamin B12 affects cysteine levels, therefore impacting zinc binding capacity, because cysteine directly binds zinc inside the ZIP transporters. And ZIP transporters import zinc into the cytoplasm. So cysteine residues are crucial for binding and transport. Now, vitamin B12 can become deficient if megalin is also deficient or lowered because of high cortisol or high-fat diet. Usually the fats do matter. The healthy fats, such as olive oil, grass-fed butter, etc., those are good for, or if those are too high, or so those are healthier fats that if they get too high, then it might not lower megalin as much, but saturated fats, they could lower megalin. Also, especially seed oils, omega-6, or could have a negative effect on megalin. So if megalin is lowered, then megalin cannot anchor cubilin, leading to vitamin B12 deficiency. Therefore, the cysteine inside the ZIP transporter cannot handle and deal with zinc, leading to zinc deficiency. This is because cysteine residues in ZIP transporters coordinate zinc ions, which are essential for zinc uptake. Here's another reason of why cysteine is needed. And of course, high fat, high cortisol will lower cysteine because the megalin is not working. And that is because immune cells, such as T cells, B cells, macrophages, like the quiet janitors of the immune system, they express surface receptors like TCR, or short for T cell receptor, BCR, short for B cell receptor, also pattern recognition receptors. And these receptors require correct protein folding. Now, correct protein folding involves cysteine disulfide bonds. So cysteine helps maintain redox environment on the cell surface, which preserves receptor signaling efficiency. So low cysteine as a result of a B12 deficiency because of high-fat diet or high cortisol can lead to misfolded receptors. Because if cysteine is low, then the cysteine is not there for correct protein folding. So no cysteine means misfolded receptors, therefore impaired immune signaling. Okay, so many people, they might adopt a high-fat ketogenic diet in order to avoid advanced glycation end products, or AGEs for short, and also avoiding the negative effects or consequences of AGEs. But by switching over to a high-fat keto diet, thinking that they are avoiding or lowering AGEs, they are still getting AGEs anyways. And here's how a high-fat diet or keto can still lead to AGEs. This is because the cysteines are reduced as a result of a B12 deficiency because of the high-fat diet reducing megalin. Because there's KEAP1, or short for KEAP1, this stays locked in as a result of the reduced cysteine thiols. When cysteines are reduced, especially persistently because of B12 deficiency, uh, they you end up, or the result is zinc stabilized KEAP1, therefore continuous NRF2 degradation. As a result of NRF2 suppressed or degraded, um, there is a reduction or an impairment of carbonyl clearance. Carbonyls is basically another word for, or is actually like a component or a constituent of advanced glycation end products. So glutathione synthesis is also reduced as a result of NRF2 degraded or suppressed. And glutathione is also needed to reduce advanced glycation end products. And if ages are going up, well, then that means the ECM becomes rigid. Or it could even go to the point of no return because amidori products or adducts. So basically, if it reaches that point, it's like a non-reversible. And then rigid ECM, or short for extracellular matrix. And I've said this already in a lot of my other videos, but the immune cells cannot penetrate the dense ECM or cannot infiltrate because of the ageism increasing the cross-linking in the ECM, making it difficult or impossible for immune cells to get in to attack cancer cells. So another thing that can reduce the cysteines, which leads to this ages, is Brazil nuts, because they're very high in selenium. And high selenium means increased TRXR activity, which keeps cysteines overly reduced or suppressed in KEAP1 or KEAP1. Brazil nuts are also high fat, which will reduce the megalin, but that's only if Brazil nuts are consumed in excess, because then the fats would become way too high. And that they're also polyunsaturated fats, which leads to carbonyl pressure or increased carbonyls, therefore leading to ages, because carbonyls are a component or a constituent of advanced glycation end products. And then too many Brazil nuts with excessive selenium and high fat leads to NRF2 being suppressed. So that's it for the video. If you're interested in more future videos, then make sure to like, comment, share, and subscribe. Share these videos with your friends and family and loved ones with health concerns. I'll be doing more further research and making more videos, so stay tuned for those if you're interested. And keep it locked in here on my channel, and I'll see you in the next video.